Wow, I actually did it. I'm in math. This is awesome. It's okay, nothing can hurt me here. Wait a second. Hi everybody, I'm Mr. Wheeler. Welcome to another episode of Lost in Math. Today we're talking about graphing nonlinear equations on the coordinate plane. A nonlinear equation is an equation whose graph does not form a line, nonlinear. So far all of our equations have formed lines. Today's lesson will get out other shapes. So let's get right into it. Our first example asks us to graph y equals negative x squared and use x values from negative 3 to positive 3. To graph any equation, linear, nonlinear, doesn't matter. If we have an input x, we pick x's to input, get out y's. This creates ordered pairs, and we plot the ordered pairs. And when we're done, hopefully we have some kind of pattern. So this one says x is from negative 3 to positive 3. So I'll start with x equals negative 3. Plug it into my equation. So instead of y equals negative x squared, y equals negative 3 squared. PEMDAS, first thing we do is our exponent. So negative 3 squared is positive 9. And then I have this negative sign on the outside. So it's asking for the opposite of 9. So I get negative 9. So when I plug in a negative 3, I get out a negative 9. That's my first ordered pair. The rest of these are pretty similar, so I'll let the editing guy take care of it, and I'll come back later. So I ended up with these 7 ordered pairs. I plot them on the graph provided, connect them with a nice smooth curve, arrows at the end, and I'm done. The next example asks us to graph y equals 2x squared, and it says to use x values from negative 2 to positive 2. So this one I'll end up with 5 ordered pairs using negative 2, negative 1, 0, 1, and 2 as my x values, my inputs, get out y's, plot my ordered pairs, connect them with a smooth curve. So get to work. So these are my 5 ordered pairs. I plot them on my graph, connect them with a nice smooth curve, arrows at the ends, and I'm done. Both of our first 2 examples had an x squared in it. Equations with an x squared as its largest variable term have graphs that form parabolas. Parabolas are kind of U-shaped objects that can either face up or down. So both of these guys formed parabolas. And we'll see different kinds of equations have different patterns of graphs. On the back of our notes, it asks us to graph y equals the absolute value of x for x values between negative 2 and positive 2. Absolute value of x, we recall. Absolute value of a number is the distance that number is from 0 on a number line. It's always positive. So it takes negative numbers, makes them positive, and positive numbers, they stay positive. So the absolute value of something is always a positive number. So same thing, it gives us x values. We're plugging in a negative 2, negative 1, 0, 1, and 2. Plug them into our function, get out a y, and we end up with an ordered pair. So let's get to work. For our first ordered pair, I plug in a negative 2 for x, so y equals the absolute value of negative 2. Absolute value of negative 2 is positive 2, So when I plug a -2 into my function, I get out a +2 for y. So my first order pair is at -2, 2. And here's the work for the rest. So I end up with these 5 ordered pairs. I plot them on my graph, connect them with a line, arrows on the end, and I'm done. Our next problem is y equals -2 times the absolute value of x. It asks for x values between -2 and +2. So same as the last problem, plug in our x values, get out our y values, graph them. So take a moment and try example number 2. So here is our work for example 2. So we end up with these 5 ordered pairs, plot them on our graph, connect them with the line, arrows on the end. If you notice on our 2 examples on the back, whenever we have an absolute value in our function, our graph is always V-shaped. It's not curved, it's 2 pointed lines. So absolute value functions are V-shapes. That ends our notes on nonlinear equations. There's lots more of different kinds of nonlinear equations. We can't show them all in this little video, but you find them the same way. Plug in input values, get out output values, plot enough, and hopefully you'll see a pattern emerge and connect them with the line. That's all I have to say about that. So, bye guys. See you next time. To find any equation, things can happen on the negative side of things, and we want to account for that. That was too much. I'm going to get some food. I'm hungry, tired. Come back later. Connect them with a knife. I can pause. Our next example asks us to graph y equals the absolute value of x. Those lines on either side of the x mean absolute value. Stabbing. On the back of our notes, it asks us to graph y equals the opposite. Positive numbers keeps them positive and turns negative numbers into positive numbers. Positive numbers? Come on, man.